and then I have an angle here, I have an angle here. The rule says whatever is here and here, they are the same, x and x. Why? Because both of them are angles within the same segment. So the rule says angles in the same segment are equal. So this, if I draw a line here, a chord, that is a segment. So the angle in this segment and this, they are exactly the same. So angles in the same segment are equal. Today I'll be talking about circle theorems. In the first part of this video, I've discussed the first aspect of circle geometry, how you can identify your segment, the chord, the arc, the sector, how to find the length of an arc, how to find the area of a sector. I've simplified everything. If you have not seen the video, I'll drop the link in the description to this video. But today I'll be talking about the circle theorems. So what are the theorems that you'll be using to answer questions? And I have simplified these theorems for you. So very quickly, let's delve in and check so that you will be able to answer questions effectively in your WAEC exams and in your NECO exams. Now, the first theorem I'll be talking about, when you have a circle, and then remember, this is the center of the circle, and then this is a chord. This is a chord. This is a chord. I discussed the meaning of a chord in my first video. Now, the first theory says a line drawn from the center of the circle to meet the chord, right? To meet this chord forms or is perpendicular to the chord. It's perpendicular to the chord, meaning that it forms angle 90 degrees to this with this chord, all right? And not that alone, it divides this chord into two equal halves. Divides the chord into two equal halves. So the theorem says a line drawn from the center of the circle to meet a chord divides the chord into two equal halves. That's number one. Number two, the line is perpendicular to the chord. Let's label the chord AB. To the chord AB, that is, forms angle 90. Forms angle 90 degrees. So the angle here is 90 degrees. Right. From this center C, that's angle 90 degrees. Now, once that is settled, how can we apply this in answering questions? Now, the next thing, before we go to the next one, if I draw a line here, you'll recall that this line is the what? Is the radius. Why is it the radius? Radius is any line drawn from the center of a circle. Yes, let me adjust this circle. Forgive the size of my circle. It's not accurate. All right. From the center of this circle to any part of the circumference is a radius. So this is a radius. So if this is a radius, that means the size of here will also be equal to the size of here. So the length of here is the length of here. Is that okay? So this is a triangle. So from this theorem, angle 90 degrees here. So you can, if you are given the value of here, you can do Pythagoras theorem here to get the length of the chord. Let's look at the second theorem, theorem number 2. So this theorem 1. Theorem 2 says that if I have a circle and then I have this, yes, the angle here is twice of the angle at the circumference. So this theorem says the angle at the center, so this is the center C. So the angle at the center C is twice the angle at the circumference. The circumference is at this point, or the angle at this circumference, at the point there, at the top here, this angle x. So this is 2x. So if here is 30 degrees, here will be 60 degrees. And if here is 100 degrees, that means here is half of what you have here. Number 3, if I have a circle, and then I have a diameter that cuts the circle into 2 equal halves, and then I have a chord here, I have another chord here, pardon my line, yeah. So the theorem says this is a line, the diameter, this is a chord connecting to the diameter at this point, this is another chord here. The angle between the two chords will be 90 degrees. So when two chords meet at the diameter, they form 90 degrees. So if I have ABC, all right, so my angle ABC is 90 degrees because at this diameter, so the chord, these are two chords joining at this angle and it makes up so 90 degrees. So here, if I label here A, B, C, D, and I've said here is twice of here, so that means my angle ACD is equals to 2 times of angle is 2 times of is twice of 2 times angle ABD. You remember the meaning of this, it means angle, and that means the angle is at the center C. So ACD. So ACD is 2 times of ABD. That means this sign means my angle is on B. All right. So number 4, if I have a circle like this, if I have a circle, and I have okay, so let's take this. I take this, and I take this. Now let me now make it a perfect quadrilateral. Yeah. So in this circle, if I have A, B, C, D, the theorem says this angle and this angle are supplementary. So angle ABC is supplementary to angle ADC. And what's the meaning of that? It means the angle, that means my angle ABC plus my ADC is equals to 180 degrees. So if I add this to be 80 degrees, then also same here and here, if I add the two together, it will be 180 degrees. So my BAD also, angle BAD plus angle BCD is 180 degrees. Number 5. If I have a circle, and I have this, if I have a chord of equal length and the center here, the distance from here to this chord, to the center, is the same as the distance here. So here and here are the same. So look at this. If I have two chords, let's say this is AB and CD. So if there are two chords equal in length, have the same distance, from the center of the circle. So the distance between here and here and here and here are exactly the same, given that the length of this chord and the length of this chord are equal. I have a circle here, and then I draw a line like this. And then I have an angle here, I have an angle here. The rule says whatever is here and here, they are the same. X and X. Why? Because both of them are angles within the same segment. So the rule says angles in the same segment are equal. So this, if I draw a line here, a chord, that is a segment. So the angle in this segment and this, they are exactly the same. So angles in the same segment are equal. If you have a circle and you have a tangent here, you have a second to the last, a tangent, and then I have a triangle, something like this. All right. So the rule says the angle between this chord and this tangent, the angle between this chord and this tangent is equivalent to the angle at this point. They are alternating, the alternating segment. They alternate. All right. The angle between this chord to this tangent that it makes is equal to this. And then the same thing here, the angle from here, from this chord, that it makes to this tangent is equivalent to here. So this is y. So the rule here says the angle a chord makes with the tangent at the point of contact. This is the point of contact. At the point of contact is equal to the alternate, to the angle in the alternate segment. Alternate segment. So this angle from this chord to the tangent, all right, is equal to this angle, and then this angle here is equal to this angle here. And lastly, let me have this. When I have a circle, then there is this. All right, so there are two tangents that are bent and they meet at this point. Okay, the rule makes us to understand that the distance of here, these two tangents that are drawn to meet at this point, they have the same distance from the circle. So if here is A, B, C, then D, E. So it means that the line AB is equal to line AD. So the distance from here to here is equal to the distance from here to here. So that is what the rule says. Now we already have 9. So let me quickly do a run through from the beginning. Let me do a run through. Number one, when you have a circle and then you have a chord from the center of the circle, a line drawn from the center of the circle to this chord, we divide this chord into 2 equal halves, and then the line is perpendicular to the chord, meaning it forms angle 90 degrees. Number 2, when you have a circle and then you have an angle at the center and at the segment or at the circumference, the angle at the center is twice the angle at the circumference. For this, when 2 chords are connected to the diameter, this is connected to a side of the diameter, this is connected to another side of the diameter within the semicircle, all right, they form an angle 90 degrees at the point of connection. Then when you have a quadrilateral in a circle, the 2 opposites, so segments, these segments, they are opposite segments, they are supplementary. All right, angle in these opposite segments are supplementary. Okay, meaning you add it up to give you 180 degrees. The angle here plus the angle here adds up to give 180 degrees. Then if you have 2 chords of equal length, all right, drawn on each side of a circle like this, the distance of this chord from the center is exactly equal to the distance of this chord from the center. Then when you have this, angles within the same segment are equal. So here is x, here is x. Then here, if I draw a tangent, the line that runs from the center of a circle to this tangent is perpendicular. The line is perpendicular to the tangent. The tangent is this line, so we can call it AT or AB. The AB is a tangent. So line CD is perpendicular to line AB, to line AB. And then the next one, the angle. So here, this is a chord, this is a line, this is a chord, this is a segment, this is another chord here, this is a third chord here. Now for this chord, the angle from this point, this line of the chord to the tangent, all right, is equal to this angle on the alternate segment. So this is another segment, the angle here. Please take note, this angle is within the triangle. This is outside the triangle connecting to the tangent. So both of them are not within, not the one within here, but the one outside here. Then the one outside here is also equal to y that you have here. And then the last but not the least, where you have 2 tangents that are drawn, all right, and they are connected at this point, the distance from the point of meeting the circle to this point, all right, they are exactly the same. The distance of here to here and this line, they are the same. Now let's try some examples to see how we can apply the theorems that we have discussed so far. In the diagram, O is the center of the circle, SQR, this angle is 60 degrees, and SPR, Y, is Y, and SOR is 3x. SOR, that's 3x. So find the value of x plus y. So we have to find the value of y and x and then add it together. The first thing you want to do is y and 60. There is something common in these two. What, can you guess it? These are 2 angles within the same segment, so they are equal. Therefore, our y is going to be 60 degrees. Angle in same segment are equal. So angle in the same segment are equal. So that means here is 60. So if here is 60 and here is 60. Now, another thing is this. If these are 2 parallel lines, this line and this line, they are parallel. So if I extend this line upward, extend this downward, extend this downward, you will see that this angle and this angle, they are what? They are alternate angles. How are they alternate? These are 2 parallel lines. This angle and this angle are alternate. So if here is 60 degrees, here also is going to be 60 degrees. The same way here and here are alternate angles, 60 degrees as well. So if that is the case, the last thing we want to do, the question says we should find x plus y. So we need to know the value of x. How can we know the value of x? We need to find here. If we're able to find here, all right, you remember the sum of angle in this triangle is 180 degrees. So to find here, all right, let's label here z. To find our z, z plus 60 plus 60, z plus this 60 and 60 is 180 degrees. Sum of angle in triangle. Sum of angle in triangle. So our z is going to be 180 minus 60 plus 60 is 120. That is 60. So that means z is 60 degrees. So if this place is 60 degrees, all right? So let me replace it there, 60 degrees. Now this point to this point is angle on a straight line. This is a straight line. So this angle on a straight line. And what's sum of angle in a straight line? 180 degrees. So I'm going to say 3x plus 60 is equals to 180 degrees. Angle on a straight line. Angle on a straight line. Sum of angle on a straight line. So that is 3x equals to 180 minus 60. That's going to be what? 3x is equals to 120. Divide both sides by 3. So my x is going to be equal to 40. So if x is equal to 40 and y is 60, and the question says find x plus y. So x plus y will be, x is what? 40 plus 60. And the total answer will be 100 degrees. So here is the answer to the question, 100 degrees. I hope that is clear. A circle of radius r centimeter, a chord 16 root 3 centimeter long is 10 centimeter from the center of the circle. Find correct to the nearest centimeters the value of r. So what we are going to do is to draw the circle, right? In a circle of radius, this a chord. So we have to draw a chord as well. So there's a chord of 16 root 3 centimeter long. That's the length. 16 root 3 centimeter, that's the length of the chord. Is 10 centimeter from the center. This is the center. 10 centimeter from the center of the circle. You remember, according to the theorem, this line from the center of the circle to the chord, we divide the chord into two equal halves. That's number one. Then it forms angle 90 degrees with the chord. So we're asked to find correct to the nearest the value of r, the radius, in a circle of radius r. So our radius is r. Our radius is the distance from the circle to any point of the circumference. So this is our radius. Instead of drawing it any other place, you connect it to this diagram. That is r, to give us a triangle. So here we have, if you put our angle here, this is the opposite, this is the hypotenuse, this is the adjacent. But since we are dealing with only half of the chord, so our adjacent is going to be what? It's going to be 16 root 3 divided by 2. Because we are divided by 2, our opposite is going to be 10 centimeters. We are looking for our radius, which is the hypotenuse, r. So we are going to use Pythagoras theorem, which states hypotenuse squared equals to opposite squared plus adjacent squared. So what is our hypotenuse squared? R squared is going equal to be 10 squared plus adjacent is 16 root 3 over 2. Okay, then squared. We're going to square it. So that's going to be r squared equals to 100 plus 2 in 16 is 8. So we have 8 root 3 squared. So r squared is going to be 100 plus 8 root 3 squared will be 8 squared is 64 multiplied by root 3 squared is root 9. And that's going to be r squared is equals to 100 plus 64 times root 9 is 3. So 64 times 3 is what? 64 times 3, 12, 18 is 192. So r squared is going to be 100 plus 192. R squared is going to be square root of, add it 292. And that's going to be our R is going to be 17.088 or 17.08. All right. And we were asked to correct to the nearest centimeters. So to the nearest centimeter is going to be 17 centimeters. Do we have that in the option? Yes. That is the answer to the question. So we've answered this question. I hope this is very clear to you. If you have any question or if you have any of the theorems that you found valuable, you can go to the comment section and type the number of the theorem. And if this video has made sense to you, go to the comment section and type value, value, value. Remember to share this video with your friends. If you have not subscribed to this channel, do well to subscribe and like and comment. Thank you for being a part of this class. See you in the next class. Bye for now.